In this lecture, we will discuss about dimensions and units. What is dimension? Dimension is a measure of any physical variable without the amount, quantity or magnitude. There are two types of dimensions, primary dimension and the secondary dimension. The primary dimension is a fundamental dimension, and a dimension which is derived from the primary dimension or fundamental dimension, we call it as secondary dimension. The best examples of dimensions are mass, length, time, temperature, force, pressure, power, and so on. Here, this mass, length, time, we call it as primary dimensions. Whereas the force, pressure, power, we call it as secondary dimension. How about this temperature? Temperature is also a primary dimension. Units. Unit is nothing but is a measure of the dimension. How will you measure the dimension? If you would like to measure the distance between this point and this point, its magnitude is, let us say, some 2. 2 what? 2 tomatoes or potatoes? Some unit is required, right? And similarly, during this particular time to this particular time, I will handle the class. That is what I say. Say, for example, 10 a.m. to 11 a.m. I conduct. What is this? 10 a.m. to 11 a.m. There should be some measurement. That measurement, we call it as unit. Here, the distance between this point 1 and 2, there is some 2. What is this? Maybe 2 meters or 2 centimeters or 2 kilometers. Something I would measure. Similarly, here between 10 a.m. to 11 a.m. I said. That means between this 10 a.m. and 11 a.m. there is 1. We denote with some unit called hour. Similar to dimensions, there is a primary unit and there is a secondary unit. The primary units are nothing but fundamental units. The secondary units are the units which are derived from the primary unit or fundamental unit. Let us see the examples. For mass, we use an unit kg, kilogram. For length, we use the unit as meter. For time, we use the unit as second. For temperature, we use Kelvin or degree Celsius. For force, Newton. For pressure, we measure with Pascal. The unit of power is watt. This is what we have discussed now. The length is expressed in meters, mass is in kilogram, time is in seconds, temperature is degree Celsius or Kelvin. Force, look at this force. As I have already explained about the primary unit and the secondary unit, this force equal to mass into acceleration. The unit of mass is kilogram and the unit of acceleration is meter per second square. Combining these two primary or fundamental units, we have derived a unit called newtons. So, this force is a derived unit or secondary unit. Similarly, for pressure also, you can say that pressure P is equal to the force acting on an unit area. So, the force is Newton. Area is expressed in meter square. So, the unit of pressure is Newton per meter square. We call it as Pascal. 1 Newton per meter square is 1 Pascal. Similarly, for power, Newton meter per second. That is, force multiplied with the distance is the work done divided by time, I obtain the power. So, this Newton meter per second can be written as joules per second. Here, this joules is a secondary unit or the derived unit, and joules per second is also a derived unit, which we call it as watt. We write it as only W. We don't write W-A-T-T. This table gives you a brief idea about the magnitudes of the various dimensions and the units. As far as our subject point of view is concerned, the length is expressed in meters Sometimes you may encounter with the kilometer. So 1 kilometer is equal to 10 power 3 meter, or 1 kilometer is equal to 1000 meters, which is equal to 10 power 3 meters. And mass, 1 megagram is equal to 1000 kilogram, that is 10 power 3 kilograms. Similarly, force is expressed in newtons. 1 kilonewton is equal to 10 power 3 newtons. 1 meganewton, 10 power 6 newtons. 1 giganewton is equal to 10 power 9 newtons. So, kilo is 10 power 3, mega is 10 power 6, giga is 10 power 9. Similarly, pressure is expressed in Newton per meter square or Pascal. 1 kilopascal is equal to 1000 Pascal or 10 power 3 Pascal. 1 megapascal is equal to 10 power 6 Pascal or 10 power 6 Newton per meter square. Similarly, 1 gigapascal is 10 power 9 Pascal. Sometimes we may encounter with another unit called bar. 1 bar is nothing but 10 power 5 Newton per meter square. So, this one bar is equal to 10 power 5 Newton per meter square. If you would like to convert this 10 power 5 Newton per meter square or Pascal into kilopascal, what we do? 100 multiply with 10 power 3 is nothing but 10 power 5, right? So, this term I can write it as kilopascal and this is 100. So, 10 power, this quantity is, this is not Pascal, this must be kilopascal. It's a typo. This is 100 kilopascal. So, 1 kilopascal is 10 power 3 Pascal. So, 1 bar is equal to 10 power 2 kilopascal or 100 kilopascal. Similarly, coming to the work is expressed in joules. Newton meter is joules. 1 kilojoules is 10 power 3 joules. 1 megajoules is 10 power 6 joules. 1 gigajoules is 10 power 9 joules. Similarly, the power is expressed in Newton meter per second or joules per second or simply watt. 1 kilowatt is 10 power 3 watt. 1 megawatt is 10 power 6 watt. 1 gigawatt is 10 power 9 watt. Similarly, sometimes we may go with smaller units. Say, for example, we'll take length 1000 mm is equal to 1 meter. So, how much will be 1 mm? 1 mm will be equal to 1 by 1000 meter. So, it is equal to 10 power minus 3 meter. So, here this mm, these terms we call it as milli. If it is a kilo, we use 10 power 3. If it is milli, we use 10 power minus 3. If it is a micro, we use 10 power minus 6. 1 micron or 1 micrometer is equal to 1 into 10 power minus 6 meter. Thank you.